All right, well, hello everybody, and good morning or good afternoon or good evening, wherever you're located. Thank you for joining us to today's webinar. Today we're going to talk about how Genesys cut time to security incident detection. When you join today's webinar, you select to join either by phone call or by your computer audio. If for any reason you'd like to change that selection, you can do so by accessing your audio pane in the control panel. And also from this control panel, you'll have the opportunity to submit questions to today's presenters by typing your questions into the question pane. And we'll collect these at the end and address them during our Q&A session once we wrap up the actual presentation. If for any reason we don't get to your question, we plan on responding to each of you personally through email. The deck will also be available through SlideShare along with a recording of this webinar in about 2 to 3 days after the conclusion of the actual presentation, so keep an eye out for that email as well. My name is Scott Ward. I am a solution architect with Amazon Web Services, and I'll be your first speaker and your moderator for today's webinar. I'm joined by Chris Jervis, VP of Engineering from ThreatStack, George Valter, who is a Senior Software Engineer of Security at Genesys, and by Jared Sexton, who's a Manager and Lead Information Security Engineer at Genesys as well. So once again, thank you for joining, and let's go ahead and get started here. So when you talk about security, protecting your data and your intellectual property is one of the most important things that you can be focusing on as a company. You need to ensure that the things that differentiate you as a company and the data that your customers have entrusted you to protect are truly fully secure. The cost of unauthorized access to this data can really have significant financial and reputation consequences. As you can see by some of the data that's on this slide, that an average cost of a data breach can take over $6.5 million of money out of the company's pocket due to the research and the things that they have to do with protecting and finding out what happened with those breaches. Over 70% of consumers have indicated that they'd avoid a business following a security breach, so that can impact your reputation and your status as a business, and that they generally are seeing an increase in theft of hard intellectual property, with that rising over 56%. So a recent IPC study also found that customers can be more secure in AWS than in their on-premise environments. And these are also statements that we have from some of our customers publicly commenting on the same story. So how do we enable that when it comes to the AWS platform? Well, we give you automated logging and monitoring. So there's the ability to get a lot of information out of the AWS platform so that you have visibility into what's going on with your particular workloads that are running on the AWS platform. We've simplified the ability to access resources, and on top of that, we've really enabled you to be able to control how people can get to and use those resources. We make it very easy to implement the proper encryption in your AWS account. We encourage our customers to encrypt their data wherever possible, and we give you different ways to do this. You can completely implement and build this on your own. You can implement a partner solution for your encryption, or you can use AWS provided encryption services that allow you to leverage encryption keys that are tied to your AWS account and allow you to do client-side or server-side encryption of the data that you're storing in AWS. And we give you the ability to enforce strong authentication when it comes to your AWS account. You can define individual users in your AWS account and apply the appropriate password policies to those users. You can define that users have to use multi-factor authentication to access your AWS account. You can even go so deep as saying that certain API calls that they make against your account need multi-factor authentication before they can actually do those calls. You can also link your AWS account with your corporate directory and enable federation into your AWS account, which helps to ensure that your usernames and passwords for accessing your account are tied to your corporate directory and that they're following, the defined policies that you've already created for how you want to operate as a business, and you don't have any lingering usernames or passwords in your account that might need to be monitored or that might follow different standards. So when it comes to security on AWS, there's no one party that has ultimate responsibility for security. It's shared between the customer and AWS. And on the AWS side, we take responsibility for the security of the cloud. And that security responsibility covers a couple different areas. One, it covers the global infrastructure. So the physical facilities around the world that AWS is using to host the infrastructure that's used to power Amazon Web Services. So we own the responsibility of securing that physical infrastructure around the world. And AWS also owns the responsibility of securing the foundational services around compute, storage, database, and networking. These are the core things that many people are building their solutions on top of, as well as other AWS services. So then the customer, they have the responsibility for their security in the cloud. So things, we're first starting with any configuration changes or configuration options that AWS gives the customer to enable certain security configurations in their AWS account. Customers also own deciding how they want to do client-side encryption and data encryption, how they're going to protect their network traffic, what kinds of things are they going to implement as far as how they're going to protect and monitor their network traffic. Customers own what they're going to do with their operating systems on AWS. So when you launch a virtual machine on AWS, you have full ownership of that operating system. You have the root access, you have the access keys, you get to control who logs onto that operating system, and you also are in charge of deciding when you're going to patch the operating system and how you're going to harden that operating system. You also have the ability to implement any additional firewall configuration you might want to put at the operating system level. Any applications that you actually launch and run on the AWS platform, it's the customer's responsibility to make sure that they actually are controlling the responsibilities and the access that people have to those actual applications, and that they are only able to do what they want to do or what they should be able to do in relation to their job. And customers are responsible for the data that they're actually storing on AWS. So customers have full ownership of the data of what they're storing on AWS, but customers also own ensuring that they know which storage services they're using, who has access to their data, and what type of encryption they're applying to the data that they're storing on AWS. So let's dive a little bit deeper in a few things that AWS offers as far as a platform to help customers feel comfortable. One of them is the ability to really be able to constantly monitor your environment, and there's lots of services that exist on AWS that allow you to monitor the environment. I think one of the most important ones is AWS CloudTrail, would actually let you monitor and record all the API calls that are happening against your AWS account and see where those calls are coming from and what information they're asking for. A service like Amazon Inspector that allows you to actually run assessments on the virtual machines that you're running in AWS to see if there's any vulnerabilities that exist. VPC flow logs that gives you the detail about traffic that's actually flowing in and out of your VPC. An AWS config, which is a really cool service that gives you an inventory of what's running in your AWS account and also gives you visibility into when the changes are made to those resources in just a few minutes to give you that visibility. And just picture how challenging that could be in a normal on-premise data center situation. We also allow you to control and protect your data. Remember, we talked back a few slides ago that the customers have full ownership of their data. There's a couple different ways that this can be implemented and leveraged for customers. It starts with our regional availability. We have 16 different regions around the world where customers can run their workloads. And one of the cool things about that is that if customers have some sort of particular compliance requirement that they need to be storing their data in a certain part of the world to meet regulatory needs, they can choose the particular AWS region that meets those needs and be able to store their data there. The other thing it enables is that customers can use an alternate AWS region as maybe their disaster recovery zone. So that if they have some requirements that need to be able to recover their data in an event of a disaster or in another part of the world, they can actually use one of those AWS regions as that failover part for their data. You get to retain control of all your data that resides in the AWS cloud. We don't move your data. Once it's stored in a region, it stays in that region. The only way it would move is if you as a customer move that data yourself, or if you enabled configuration in an AWS service that said, I'd like my data replicated to another region. So you have, once again, strong assurance that you can meet regulatory requirements where you store your data in the AWS cloud. We have services like AWS Shield that actually allow you to prevent your infrastructure and your applications from DDoS attacks. So they're looking at, kind of looking at the traffic coming into your account and applying the mitigations and the protections that may be required to help prevent those DDoS attacks. And once again, you can implement the encryption that you want on AWS to protect your data, whether it be data in transit or data at rest. You have the ability to implement the encryption that you need to make sure that your data is safe and protected at the levels you want it to be. There's also the ability to integrate your existing resources and processes with what you're doing on AWS. You know, a lot of companies are using some sort of a corporate directory such as Active Directory. You fully have the ability to continue to integrate your corporate directory into what you're doing on AWS, whether you're going to continue to run that directory in your on-premise data center or run that in AWS. That you can still bring it along with you and use what you invested in for that directory to ensure that you're following the right procedures and levels of authentication that you want to have in your company. You can use dedicated connections via AWS Direct Connect to get a dedicated link between your on-premise data center and the AWS region to give you that private connection and low latency extension into your data center to have more of a hybrid type environment. You can provide and manage your own encryption keys if you want to, so you can bring your own keys and use them on the AWS cloud. And one of the key things here, and especially relates to this webinar, is that you can implement partner security solutions on the customer portion of the shared responsibility model. So if you have some sort of additional security tool or partner solution you want to use to help you meet your security profile, that's the whole thing of the AWS shared responsibility model. You can bring those solutions, implement them, and run them to help you achieve that profile as part of what you need for security on the AWS cloud. And we have lots of different customers on the AWS platform. We have millions of different customers operating in the enterprise, the government, and the startup space. These customers at times are operating in industries or with businesses that require that they meet certain levels of compliance. So the AWS side has implemented a certification and assurance programs that help to ensure that the AWS portion of the shared responsibility model is meeting the requirements of these certification programs that we're working with. This is a small sample, as you can see on this slide, of some of the programs we're working with. If you go to visit the AWS compliance page, you'll see the full list of all the different organizations that we're working with. But what this means is, because we're working with these bodies to make sure that the AWS portion of the shared responsibility model is compliant, that customers can then take and run and implement their workloads on top of AWS. And they just have to worry about enforcing the audit compliance requirements for what they're running on AWS. They don't have to worry about the infrastructure and the facilities underneath, because AWS is already taking care of that. So they have the ability to then take the audit findings from their application that they're running on AWS, combine those up with the third-party attestations about what AWS is doing to meet compliance requirements, and be able to show that they have a fully compliant solution running in the AWS cloud. So with that, I'm going to turn over to some of our other guests today, and we'll start it off with Chris from ThreatStack.
Great, thank you, Scott. So before we listen to George and Jared, and we're going to get some stories from them and some insight into how they executed not only their security journey, but focusing really on incident detection and how they cut their time, it's worth revisiting for a moment that strong infrastructure that Scott just mentioned. As we look at the next slide, which has, again, the recitation of the AWS shared responsibility model, one of the most important things that occurred is that strong foundation that Amazon has provided customers to move to the cloud with confidence. So from a security perspective, you're able to eliminate a whole host of concerns, but now you have to learn some new approaches for security in the cloud. You have to understand your workloads better. You have to understand how you're provisioning your instances, how you're managing your assets, and the notion of the network has changed. Your network now is the collection and relationships of all the assets that you have running in AWS, both things you're running yourself, as well as the services and capabilities you're taking advantage of from AWS that are intrinsic to your application of your business, that are storing sensitive data, and that are doing the business processing needs that you have. How all those fit together, how they communicate, how they're touching customer data, and how users are interacting with them are very critical for your security posture. So as we go through and hear what George and Jared have built up, we're going to get great insight into how they've approached this and how they can go on to achieve an amazing level of automation resting on top of the AWS services, and also using ThreatStack as part of that security wraparound solution. So with that, let's go forward and hand it over to George and Jared to get started.
All right, great, thanks, Chris. So I'm going to go ahead and start us off just by introducing Genesys as a company, talk a little bit about our PureCloud product, which is our cloud native offering, and then I'll hand it to Jared for a bit. All right, so brief introduction to Genesys. We are a world leader in omnichannel customer experience and customer engagement software. We're headquartered in Daly City, California. We have both on-premise and cloud-based offerings for customers of all sizes. We currently have over 10,000 customers throughout 100 different countries. And our product portfolio currently powers over 25 billion contact center interactions per year. So moving into PureCloud, opening a new chapter. PureCloud came out of an initiative within the company to build the next generation contact center platform. To achieve this, we built a 100% cloud native solution using a microservices architecture on top of AWS. And today that's comprised of over 150 different microservices. And this design has really brought some really significant benefits. First of all, we've had faster deployment times. That's a big one. And we'll dig into our deployment pipeline further in the presentation. Greater flexibility. This allows each service to be built with the tools and technology that best fits its needs and allows them to be deployed independently. Cost-effective scalability. This is things like demand elasticity. And some other benefits like self-healing and fault isolation. Okay, so that's kind of some introduction, and now I'm going to hand it over to Jared to start talking about some of the security aspects.
Thank you. So on the slide, one of the main things that we wanted to point out that's really not explicitly called out is that VM sprawl is a real thing when it comes to public cloud. It's very easy to spin up resources, and it's very easy to forget about them. So a lot of our focus has been around visibility into the environment as well as our infrastructure and the assets that we have out there, as Chris alluded to with the shared responsibility model as well. Low high level PureCloud as well. We operate out of 4 production regions, and they're logically isolated from each other. So we have a heavy focus on ensuring consistency across the environments and a heavy focus on alerting on anomalous inconsistencies between there. Common example is we know what instances should be publicly facing in our production regions. So we can look across all 4 production regions and find an anomalous instance out there. Why is that running in Tokyo but not running in the US, right? So that's an event for us to look deeper into. So how are we securing my data? So a lot of times we use as much native offerings from Amazon as we can, including security groups for firewalling, managed NAT gateways, as well as Amazon's key management server and built-in server-side encryption for EBS and S3. Beyond that, we've gone beyond just checking some boxes. We heavily employ S3 bucket policies on sensitive buckets. The way we do that is we make it to where our employees actually cannot access that data. Only the services on the back end can. We consider that kind of, call it an insider threat policy, but it's really a need-to-know basis, least privilege concept. You might have access to the console for certain things, but you still can't have access to certain data sitting inside S3. Another solution that we developed in-house was root file system encryption on EC2 instances. What's interesting about this is we use ephemeral passphrases. So at deploy time, we actually do the full disk encryption, and we generate a passphrase on the fly, and that actually stays in memory. What's cool about this is that passphrase is only good for that unique instance, and when we blow away that server, the passphrase goes away with it. So there's no way to recover that data if, worst case scenario happened and, hard drive got taken or something like that. There's no way to actually get that encrypted data and decrypt it.
All right, so now I'm going to talk a little bit about our build and deploy approach. As I mentioned earlier, the PureCloud platform is made up of roughly 150 different microservices. And each one of those services is owned by a service dev team from cradle to grave. So kind of everything from development to operations, which also means that those dev teams are responsible for getting their service deployed. To help kind of facilitate those deployments in a well-controlled and regulated manner, we provide a single pipeline for all deployments to use. And the pipeline is shown here on the slide and has several key components, kind of starting with a Git-based version control system on the left. Each microservice is stored in its own repo, which includes not only the source code for the application, but also infrastructure definitions such as CloudFormation templates, Ansible playbooks, and some custom build scripts that Jenkins can use. Jenkins takes all that and uses tools like Packer and Ansible to bake that service on top of what we call our base AMI. This is a bit like a golden image. It's something we update at least every week with the latest OS patches and any other updates or changes that we want to be rolled out to all of our services. When Jenkins is done, we end up with a deployable artifact in the form of an immutable image. And we call that the service AMI. And that then gets pushed out to the environments, starting with dev. When that service AMI is in the deployment process in an environment, there are some Ansible playbooks which were baked into the image as part of that deployable artifact that are used to perform some final configuration steps just to get that service up and running and configured. Once testing is successful in a tier, it can then move up to the next tier until it reaches production. Even once that service is in production, though, we put it behind what we call feature toggles. And this just gives us much more granular control over how that service is actually brought into use by the rest of the production platform. So now we've kind of seen the deploy process, we can look at how security fits into the picture. To begin with, something simple is in your version control system, you can do things like code review or pull request approvals. Those are kind of great ways to get involved. And if we move over to Jenkins, this is a great place to add in downstream jobs for things like code analysis or dependency scanning. Then inside that baking process, we leverage Ansible to handle the threat stack install on every build, and also perform any OS hardening or config modification that we want done that wasn't part of the base AMI. Once Jenkins has actually produced that deployable artifact, we actually are able to detect that it's been created and kick off some automated vulnerability scanning. And this is actually a really cool system another engineer on our team built, and it ends up performing over 8,000 vulnerability scans a month. And it in itself is a bit of a microservice. It stores all the results in a DynamoDB database. It's got a REST API on top of it for retrieving results. But then once that service has been scanned and is being pushed into the environments, that's where we go ahead and configure the threat stack agent to come online and check in. And we can perform some other final audits just to look for any security concerns that might have been introduced. So now, Jared, I'll go ahead and give it back to you.
Thanks. As a service provider like AWS, we have to worry about many different objectives as we work across many verticals. We don't sell just into finance or into insurance. We sell across the board, really. And as we built out our security program, we primarily focused on the security of the platform itself. Visibility is highly important to us, as well as continuous monitoring, with automation always at the forefront. By extension, we also had compliance objectives that we wanted to achieve. HIPAA and PCI have been the main focus for us, while also maintaining SSA 16 and ISO 27001. We've felt good success with being able to use native AWS services for ones that are HIPAA eligible, as well as ones that are PCI eligible, as a speed to getting compliance in the environment. It's also worth noting for us that the way we built out our program, we've done it around the notion that you can be secure but not compliant, vice versa. What we really mean by that is, we don't stop at compliance requirements. We try to build security into the platform and then look into whether the gap analysis that's left over from the compliance requirements. So yeah, for the right level of visibility, PureCloud is, as George mentioned, is microservice architecture. So we have a need for highly available and distributed systems. In that scenario, we've opted to go with a more host-based approach to visibility. Reason we don't have a traditional perimeter like you'd see in your more traditional data centers. We don't have anything where we can just tap into a span port and drop an IDS system on, for example. And as you saw in our build and deploy pipeline, we rely on configuration management and automation to ensure our tool sets are installed and configured properly. For us, it's very important as the platform scale up and down at any time. So that means, you know, at one point we can have 2,000 instances running in production, and then, you know, a big load event happens. A lot of calls come through in our platform, a lot of logins happen, something of that nature, and some of these microservices can start scaling up. So as they scale up, our tool sets get installed and configured on those at the same time. So it's a very dynamic thing. So we never have to worry about a gap in our environment from a visibility standpoint. On top of this, we also use Amazon APIs heavily for various other things. Knowing, you know, insecure security groups, for example, is one thing that we search for. Known ELBs, looking at roles, a whole bunch of different things that we do. Going to threat stack, we've, as you saw that we put that into that pipeline, we've tended to be very much like an attacker. So we look at things that an attacker is going to do. A couple of us on the team are actually former pen testers, and you know, we kind of have a belief that if you don't know how to properly attack it, how can you properly defend it? So we've tuned threat stack to do things like tell us when somebody runs ID, or tell us when somebody runs who am I, or somebody tries to curl something, try to install a package. The benefit of the immutable images is that none of this, for the most part, should happen on a production system, especially something like installing the package. Somebody installs a kernel module, that's obviously a very high risk thing that we are heightened on, and a security engineer would get paged within a minute.
Okay, now I'm going to go ahead and start talking a bit about incident detection or security event detection. To start off, I've got a quote from the 2017 Data Breach Investigation Report, which says, focus on increasing time to exfiltration and lowering time to discovery. By doing so, hopefully, you can stop incidents from becoming breaches. I think this, you know, just really sums up how important it is to properly handle that incoming flow of security events. You know, but the problem is that oftentimes security teams are just flooded with inbound events, and it's difficult to filter out noise versus events that might actually be pointing to some malicious activity. You know, unfortunately, one result of that, as you can see in the chart on the right, is that 27% of breaches end up being discovered by third parties. So for us, you know, all this really drives our defensive mentality that Jared was just talking about. You know, when it comes to security event detection, we really try to think like an attacker. And we're fortunate to have, you know, guys like Jared and others on the team, you know, that have that pen testing background and have tuned threat stack to really detect the events that we're interested in. But even with that, like most organizations, we face a high volume of security events every day. And that brings me into our next slide here. So we quickly realized, you know, as a team that in order to solve the problem that we were just discussing, you know, we had to get all of our security events into one place where they can be viewed, managed, and even allow for some automated responses. So in the screenshots here, you're looking at a system that we've been building out over the last few months. Internally within the team, we call it NORAD, but it's essentially a security event manager or a centralized SecOps dashboard. It's a web application that we've built on top of AWS, and it leverages services like EC2, DynamoDB, Lambda, API Gateway. And it's just a system that collects all of our security events from the different sources. So threat stack, AWS config rules, other custom security apps and scripts that we've written, you know, other tools we use. And there's a few major benefits that really made the investment into building this tool worthwhile. I think first off, you know, our security engineers no longer have to swivel chair between systems to watch for all the different sources of incoming security events. In addition, it gives us the ability to do what I kind of call smart alerting. You know, this lets us route alerts based on not just severity, but also, you know, environment, time of day, who's on call, you know, things like that. And third, probably the biggest one, it opens up the potential for some automated response. In the screenshot on the lower right there, you can see a YAML-based configuration file, which drives the automated response component within the system. And a lot of times these are simple actions, but it can also be a complex chain of actions. And a lot of times, the goal is really to build some context around the incoming event, because it just really decreases the time it takes you to figure out if this event is maybe some noise from some routine activity, or if it's something that one of the security engineers should really take some time and dig in deeper. Okay, and Jared, go ahead and get back to you.
Selling security internally. As you can see, the main point for us is that numbers are your friend. Too many security teams are looked at as just the cost center. It's the cost of doing business. It's a necessary evil. For us, we think that should actually be kind of flipped around. We're actually a very active team on the sales cycle. We've had scenarios where salespeople have come to us and said, this deal's not going to go anywhere until you get on the phone and talk to them. And that's something that we do, and we're happy to do that. We've also found that the compliance objectives that we go after, as I mentioned, HIPAA and PCI, two of the main ones, have actually helped forge a bridge to successfully closing these deals. We're seeing this a lot in especially larger organizations where they have a much more mature vendor due diligence process. And lastly, we're finding the speed of response and being able to show it through live demos has resonated well with executives. Usually when we're going in and showing what our team can do, we don't just do PowerPoints. We'll actually get on a machine, start messing around, showing the alerts coming in, showing it hitting a pager. And that's gotten really great feedback on just seeing how quick that something as simple as, a curl on a production machine can end up in the hands of a security engineer who can already start investigating those alerts. So we're going to talk a little bit about build versus buy from a kind of a security philosophy standpoint. Small anecdote on this. Before we started actually doing a proof of concept and ultimately choosing threat stack, we did what we usually do, and I went down the route of just building a solution. In this scenario, we were looking at OSSEC, and we were looking for ways to pretty much put this into our dynamic environment, right? The same way that we're doing threat stack on deploy, go ahead and register an agent, configure it correctly. We found some issues though, where every couple of weeks, deploys would start failing in the lower environments. This never made it to prod, but in the lower environments, deploys would start failing. As we started looking into it, we realized that there was actually some stuff in the code that stopped us from being able to go beyond where we wanted to. And as you can just see in the code here, you'll see this if I is greater than or equal to 4,000, and then you'll see here where this integer I equals 1024. What we found that was happening was every time a registration would happen, the very first agent would start at like 1024, 1025. And the next one would be 1026, next one would be 1027. Well, when it tried to actually do client ID number 4,000, it would actually explode and wouldn't let you register anymore. So we were only able to register about under 3,000 agents before all deploys started failing. Another issue we found is, as you can see here with this error message down there, is that even if we wrote code to go ahead and do something like if the agent isn't reporting for 24 hours, go ahead and remove it from the server, that actually wouldn't free up the client ID. It would just pretty much put a whole bunch of pound signs in the client.keys file. So let's say we had 100 registered agents, but we had 2,000 before that. The next one was actually going to be down into the 3,000s and wouldn't actually go take on a previous client ID that's no longer being used. So even trying to clear out agents via automation, we'd run into a client.keys file actually getting filled up and having the same kind of issue where deploys would start failing. So on top of that, because as I mentioned, we have 4 logically isolated production environments, there would have been a burden on infrastructure costs. We would have had to run these servers in every production environment, as well as a lot of work to actually try to pull data out of each one and try to aggregate it into something like the centralized dashboard that George just showed. So a little more about build versus buy for us. We kind of ask these questions, and it helps us to kind of just quantify it a little bit. Will building it require more than one engineer? And really, it's not just building it, but also maintaining it and supporting it. If it's not something that one engineer can do, or can be, knowledge shared across the board, then that's where we'll look at something and make it a little more of a strategic purchase. As you see, can your homegrown model scale with your organization? The previous example, as I just showed you, we failed after, a couple thousand deploys. A lot of people might think, well, that's a lot of deploys. Well, for us, a couple thousand deploys is a week and a half, 2 weeks maybe. And then what key features will you be missing? It's another thing. As we look at build versus buy, what can we do on our own versus what's the value add on top of this? And then this is pretty much a bit of a catch-all. That's obviously not exhaustive. It's just a high-level idea. But some of the best practices we found for managing AWS security, make MFA ubiquitous. That's a big one. I think we all know just username passwords causes a lot of issues. Having that MFA there is really nice. Automate where you can. We're a big fan of letting data and letting code do tasks that a human doesn't need to do, so that we can free up a human engineer to actually do the things that are not trivial. A good example is a really good web application pen test. Code just can't do that for you. You need somebody that's skilled and can understand how to attack an application. So taking some of this work away of going to search for all these different data and all these different systems and stuff, and just letting code do that for you has really helped us out and freed up at times. Visibility matters. We've talked about it a lot. How can you secure something that you don't know about? But one I really wanted to touch on was deploying often comes with great benefits. As I mentioned, we deploy a lot. And one thing we do that's a little different with the immutable images, as George talked about, is we don't deploy code on existing systems. When we deploy code, with it comes a brand new system. So what's nice about this is we aim for a maximum deploy of every 30 days per service. Many of our services will deploy more often. And where there's benefit here is, one, whenever they deploy on a new base AMI, the security patches come with it, so we don't have to patch in place. So patch management's a little easier for us. You don't go say, oh, these 150 things need this. No, you just deploy one more time, and there's your patches. Also, what's nice here is it kind of kills off the idea of persistence and maintaining a foothold in an environment. If a compromise did occur and they tried to do something, they've got a pretty small window of things that they can do before a deploy comes around and just completely wipes away that. So they'd have to do it all over again. Even with the visibility we have built in, it's just a nice layer on top of it. And then as we showed with our deployment process, we build security into the development pipeline. So every step of the way, we want to build security into it. We want it to be where when it's time for a developer, systems, service owner to open up a change management ticket, we've already done so many checks that we're pretty comfortable with that going into production. So that's all I have. I'll hand it back over.
Great. Thanks, guys. That story and the power of what you talked about, for me personally, it's so great to hear, because honestly, one of the reasons why we built ThreatStack in the first place was provide that level of capability for companies to worry and focus on being a secure company and not have to worry about being a security company, and really focus on the things that are going to differentiate themselves and focus their efforts. So what I'd love to talk about is, ThreatStack was built in the cloud and for the cloud. But one of our unique capabilities is that as many companies are going through the transition to the cloud, we can really help cover both domains there. In terms of, as workloads start to migrate, you can see how we work, install us both on-prem and in the cloud. And as you're bringing your workloads over, and your users and your automation and configuration management and updating your security strategies and patterns, we'll grow and move along with you. So out of the box, ThreatStack provides some really important capabilities that, regardless of where you're running, but especially if you're running in the cloud, help you stand on top of that strong infrastructure that AWS provides you. So for instance, we've got the real-time host monitoring, which is the very deep visibility into what users and processes are doing across your host assets, your instances. And we provide with you out of the box a set of curated rule sets that we ship to have been built in all the security best practices that we've been able to learn over the years and that we continually publish in there. And this forms the basis for the threat stack platform. On top of that, we're able to do things like vulnerability monitoring. And you saw from previous slides, George and Jared, where they got vulnerability monitoring built into their CI/CD pipeline. We're able to take it another step further, where we're not just telling you that you've got a vulnerable package on your system, but you can quickly see, okay, if that vulnerable package was about Apache, let me look and see how has Apache been running, what users have been running Apache, what arguments have been run against Apache, has it been trying to fork a process that it shouldn't, trying to execute a batch shell script maybe based on a known RCE. So you can now take your alerting and investigation into a whole different level of protection because we're able to match that vulnerability data with the real-time host monitoring you get that is all about your workloads. And in addition, with the threat intelligence correlation, you can see not only what your stack is talking to internally, but what's talking to it externally. And are you getting accepts and connects into your processes by IPs with very low reputation? And then you're able to shift your security strategy around that. Perhaps you need to update your security groups and other types of firewalls to deal with that. On the right-hand side here, you see some of the values in the business benefits that Threat Stack provides around continuous compliance. Compliance is a driver that we hear all the time from customers. It's one thing to become compliant. It's another to stay in compliance as your software changes, your business needs changes, your architecture and infrastructure changes rapidly. And as you heard from Jared and George, they're on a very quick iterative cycle with their infrastructure to support the business. You need security platforms that not only can keep up with that, but that are going to allow you to focus on doing that, knowing that you can scale securely. Scott mentioned, again, a number of things about services that AWS provides. We build on top of that with our configuration auditing to make sure that you've got visibility into how you're using some of those services. So, there's been a lot of press recently about about folks who have left S3 buckets wide open. Again, things that we're able to spot very, very quickly for you, so you can narrow in on exactly the asset that you have in AWS and take corrective action really, really quickly. And then finally, I think, again, building on what George and Jared articulated really nicely, is integrating into your workflow is critical for any solution that you are investing your time in. And sometimes you have tools internally that you're using already that you might not think of as part of your security portfolio, but with something like Threat Stack can now become part of your security portfolio. So for instance, we use internally, and our customers do, tools like Slack and PagerDuty to give security a new voice in operational awareness and incident management. And now you've taken a tool you've already invested in, and you're now making it part of your security strategy and broadening it even further, so you can drive more value out of it. One of the things that makes us unique and different is really the focus on reducing your mean time to respond to an incident. And this is really the organizing principle of the webinar we've been talking about, and that Jared and George highlighted, is we want to make sure that we can provide a platform so that it's not just dealing with alerts and understanding what's happening, but knowing what to do. Do you have the right context to make a decision? So, reducing your mean time to respond is one, but kind of before that, we also want to focus on reducing your mean time to make a decision, to understand is what I'm looking at something I need to worry about. So an example here, for instance, that you can see almost like a kill chain example here with Threat Stack, where you could have an actor come in and start to attempt to disrupt your infrastructure, your workload through a known CVE that, again, we can point out and show you that's there. An alert can pop because you've seen now a connection made from a blacklisted IP. And again, so we're able to connect those data points together. You can see where perhaps they're able to take advantage of an RCE and execute some code that has allowed them to escalate their privileges, right? So from that point, you'd be able to see in Threat Stack a privilege escalation event happening on that system, and you can see, again, all of the correlating information around that. Now, perhaps this actor is going after some customer data, so they've figured out what files on your system are potentially holding some confidential information. Maybe it's about customers, Or maybe it's things like your certs or SSH keys, so that they can leverage a lateral attack methodology to get around to more. And then finally, maybe they're exfilling some data, right? So as I think as Jared mentioned, you start to see things on a production box that you shouldn't see, like curl running, why am I curling out? Why is curling these files happening out to these endpoints outside my network? These are all, common even amongst themselves, just those little things together. If you can't see them all in context, not only can you not respond quickly, but also you can't make the right type of decision about how to respond, what to escalate, where to focus on. And with ThreatStack, we provide you the context in order to do that. So again, our goal is security that supports your organization's business objectives. We want to make sure that your security operations velocity can be increased. And we've seen examples from customers where they've told us we've been able to go from things that took us hours to minutes. Real-time visibility of the behavior is very, very critical. Your users are changing, your infrastructure is changing, your code is changing. You need that visibility into the behavioral shifts that are happening and how to adjust for that. As Scott mentioned, with the AWS environment, things like CloudTrail provide that continuous flow of events. ThreatStack taps into that on your instances, through CloudTrail, and through other data ingestion, so that you can have that continuous monitoring and alerting across your entire environment. And even if you're running some workloads on-prem, we can extend to that. And then finally, I think, again, around the area of compliance, being able to match the policies and procedures you have with the automated controls through workflow integrations, through APIs, to achieve objectives of SOC, HIPAA, PCI, all the word salad that you get when you're dealing with compliance. You need to focus on how do I achieve those, not trying to build all this yourself and worrying about integrating it together. And ThreatStack helps wrap that up. So with that, that concludes the ThreatStack part of this. And what we'd like to do now is move over into the next part of our webinar.
Excellent. Oh, thank you so much, Chris, George, and Jared. I appreciate you guys being speakers and participating in our webinar today. We're going to transition into our live Q&A. So a reminder for all the listeners, if you have a question you want to ask, please put that into the question box, and we'll do our best to get to that live, or if not, we'll follow up via email. Also a reminder for all participants, we will be sending out links to the slides used today and the recording. You should see that in 2 to 3 days, so that will be coming your way very shortly. So to start with, I'd like to start my first question. I think we're going to direct this towards the Genesys folks. So for George and Jared, do you have an example of how some of the automation you did on the security side helped improve response time to a security event over maybe how you would have handled that event manually before?
Yeah, I think a good example is probably one we're actually working on right now. And a big part of our infrastructure we talked about is the fact that it's immutable, so people shouldn't be making any modification to a running instance. And so for that reason, SSH is something that's really watched closely in production, to the point that we alert inside of ThreatStack every time an SSH connection is made. And to really respond to that properly, our engineers would do some due diligence, such as looking at the IP information and verifying that the connection was from a valid Bastion host inside our environment. They might go into PagerDuty and say, is there an active alert, and maybe this engineer is trying to troubleshoot a problem. Or go into our change management system and say, is there an open, emergency change where they're looking into an issue? And those are all things that can be done programmatically. So what we're doing right now is, taking those alerts directly from ThreatStack, using the APIs of EC2 and all the other systems that I mentioned, and bringing all that data into the event, so that by the time it actually reaches our security engineer, they already have a pretty high level of confidence that either this is a valid use case where an engineer just has to get into a system, or this really doesn't add up and I need to look at this right away. So a pretty big time saver there for that engineer, because it's several systems they'd have to stop what they're doing, get into those, and do all that manually.
Yeah, and so
excellent.
To add to that, like another example that we've been playing around with is VPC flow logs, and actually looking at the outbound connections that our servers are making, and being able to automatically do things like whois lookups and NS lookups, starting to bring in some threat intel stuff. We do already use threat stacks, threat intel stuff, but also various other places that we can search that IP to see if it's a malicious IP and being able to alert on that. We're really looking at initiated outbound connections, not necessarily an established one that's going to happen, but in instance, actually going outbound and initiating that connection is a good way for us to start picking up on a little bit of breadcrumbs, start digging a little deeper.
That's great. Well, thank you very much. Chris, I think this question actually will probably be for you and some details about threat stack, but machine learning and artificial intelligence are kind of the hotness and the buzzwords lately, and it can be very useful for analytics to get valuable information out and maybe even generate some predictions or insight. Are any of the features that are kind of tied to AI and ML part of the threat stack solution today?
Yeah, it's a great question. We base a lot of the analysis we do on some statistical methods to help understand frequency and occurrence of events to be able to tune the alerting for customers, for instance. And then as we look at series of events over time, one of the things when you're looking for anomalies is, of course, defining what anomalous behavior means. And so what's useful for us, before you get into the sort of murky world of unsupervised machine learning and then, AI perhaps to interpret the results and then, maybe take action is, while we're constantly using, our own internal algorithms to look at the data to help pull signals out of that surveillance field. So it's very much a signal detection type of activity. One of the things that we do is we do put humans in the loop. So, we want to have folks who've got a deep security background on the threat stack side, work with customers to understand some of the events they're seeing, to then reset their own baselines, for instance, around their behaviors. One of the interesting things that we get to see in working with so many different customers is just the vast differences of not only the types of infrastructure and architectures people are running, but the type of allowable behaviors. And what one customer will consider an anomaly, another considers absolutely normal. We have some folks who, for instance, are smaller and because of their environment, allow their engineers to log into production machines and run commands on them directly, right? We have others where, if anybody logs into a prod machine that's not an automation user, that will instantly fire a Sev1 alert, likely schedule, instance termination of that node because it's now dirty, it's been touched by human hands. So, from that perspective, we see so much variation that we like to interpret the data and then roll that back into the app. But we're always looking at some very advanced statistical and data analytics techniques to really advance our customers' ability to deal with security.
That's great. Thank you so much, Chris. The next question I have is I'm going to start off with an answer, and then I'd like to open it up to the Genesys side to hear how they approached it. But the question I have is, how would you recommend getting started with automated event response? And from my side, on the AWS side, I'd certainly say, if you're defining a particular event that you know about or rules for a particular event, the next question should be, what would the action I'd like to take against that, and how can I automate that? And certainly on the AWS side, there's lots of APIs you could call to maybe isolate an instance with security groups or things like that. So certainly thinking about, if you've defined an event you want to watch for, what's the response you would want to take for? But there's also probably some historical analysis around going in and looking at when I've seen this event before, what are the steps that my humans took to resolve it, and is it a reproducible thing that I can kind of replace with code? Are kind of some of the generic things I'd give as far as getting started. But on the Genesys side, I'm sure you guys have had to deal with this as far as moving something that was done by a human into automation. How would you recommend getting started with some automated event response?
Yeah, I'll jump in real quick and then let George go from there. One thing that we jumped in right away on, especially because we're fully in AWS, was as you mentioned, the APIs. We do a lot of Python internally, so pulling down Bodo and actually just messing with it, and then finding out that we can do things like step through security groups and look at the IP grants and search for 0.0.0.0/0, which translates to open to the world, right? And then start being able to parse that data and working with webhooks is another thing that we do. So actually sending that to, a chat room, a notification room, sending it to, George mentioned with NORAD, and then letting NORAD route that to the proper webhook. That's where we really jumped in, and then from there we just started building on top. Let's start looking at things like open security groups. Let's start looking at our RDS instances and the security groups with that. Let's start looking at EOB security groups and making sure that they only have listeners for 443, where and there's not some other listener out there. So that and then being able to really kind of get a good feel or a fingerprint of what the environment looks like, and then start alerting off of data that's not consistent with what we expect.
Right. Yeah, excellent. I think that one of the messages there certainly is that security monitoring and security automation is a job that's never done. It's kind of a continuous improvement type approach where you're always going to be looking at things and seeing how can I tweak this, or how can I respond to this better, or improve the way I look at things. It's never going to be a one and done type approach.
Correct. Yeah, and we use software a lot as well to know when there's new things happening. Like oh, look, there's a new RDS instance that's been created. Okay, now we know about this. Is this going to be a new thing in our environment? Yes, it is. Okay, let's look at what this is supposed to do, right? And then try to build in auditing based off of that. Look, if there's a new instance, let's look at its configuration. Let's see if there's something that doesn't match with the standards that we have or the consistency that we have across the board.
Okay. Good, and we've got time for one more question. Then I'll open up to all our presenters. Is what types of security events have you found to be the most important to start with? Do you think that workload or user focused events are more important, or are they equally as important? Where do you feel that you need to start, or what did you find most important to start with?
I think we really started with user-focused events. That's really how we've tuned threat stack, and those to us are typically the most anomalous because it's very normal to have our systems doing activity. It's not very normal to have a human doing activity, and so like I said, threat stack's definitely tuned that way. We tune all of our CloudTrail that same way. We're looking for users that shouldn't be doing a certain activity, or we're looking for failed logins, things like that.
Yeah, this is Chris. I would agree with that. Oh, sorry.
I was going to say that's one thing that we've taken the extra step is we just don't look at failed logins. We also look at the geolocation of that, right? So we're starting to see a whole bunch of failed logins from a high-risk country, and it's going across many of our users. Now we're going to dig a little deeper to see, okay, they got our user base somewhere, right? And then start going down that rabbit hole of what else is this IP been trying to do.
So I definitely agree that I think, from our perspective, or at least from mine, I think starting with users is a really good place, especially if you've invested in automation, much like Jared and George have, because now you can really quickly isolate on the anomalous behavior in your environment. And it might be things like, making sure from an insider threat perspective that you're alerting you never want to see a ex-employee's user ID show up anywhere, for instance. Looking for things like that. Or again, where, maybe it's not necessarily truly a security incident, but somebody went outside the policy. If your policy is that, nobody should be able to log into a prod box, but yet you see somebody logging in to do something, it might not be a traditional security incident, but something that you need to go address because, a team member is not following process. So the user stuff is a great place to start, especially if you're starting from compliance as well, because there are many compliance regulations that require you to, note and alert on user behavior like that.
Excellent. Thank you, everybody. And on that note, we're actually going to wrap up today's webinar. So once again, thanks to all our speakers who participated today, to Chris, to George, to Jared. As a reminder, you're going to receive an email from the next 2 to 3 days with a link to the slides, as well as a recording of today's webinar. So be patient, and that'll come through soon. And I want to thank everybody for taking the time out of the day to attend this webinar. I know we're all busy, so we appreciate that time. And if you have any other questions, please don't hesitate to reach out to us. And thank you very much, and have a great day.